Hello everyone, welcome once again to the African Tech Gurus. Remember, this is your channel where learning is by doing. So today we'll be talking about the bit manipulation, and in this particular video, to be specific, what I will be covering is the quiz, explaining to you all the quiz, explaining why do we have the answer that we will choose and not the other answers. So let's first of all take you through, understand what's the outline that we have for this particular video. One is the conversion of hexadecimal into decimal. Two, the conversion of decimal into binary. And three is the conversion of binary into decimal, conversion of decimal into hexadecimal. And last but not the least is taking you through the quiz, so that we'll do together the quiz and be able to understand why do I choose a specific answer and not the other answer. So guys, if you're new to this channel, please do us a favor by subscribing to our channel and hit on the notification bell that you will be notified next time we post a new video on the same. Okay, let's now get into it and see how we're able to do it. First of all is that we're doing the conversion of hexadecimal number into decimal number. And what I will do is that I will give an example. So hexadecimal number, first of all, you have to understand that hexadecimal number is to base 16, but decimal number is to base 10. So first of all, maybe I can let you know that hexadecimal number is to base 16. Let me say it like this. It is to base 16, while decimal number, I'm using just initial D, is to base 10, while binary numbers is to base 2. So that's the difference between the three type of number system that we're talking about today. So we have base 16, base 10, and base 2. Now guys, let's get into having hexadecimal number into decimal number. So first of all, let's have a look about hexadecimal number. For example, I will have an example here as I'll have my example as, let's say example x 0, first of all 0, x 1 4 4, like this. So in this case guys, this is an hexadecimal number. Why do we say that it's an hexadecimal number? This one, what you are having there, sorry, let me use the red pen. What you are having here is hexadecimal notation. This is what tells you that this particular number is an hexadecimal. This is what's called hexadecimal notation. And then this one now is the number itself in hexadecimal number. That is, it is to base 16. So this number is 0x44, meaning that it's an hexadecimal number because we are getting to know that by this 0x. It's able to tell us that this one is an hexadecimal number. That's what's called hexadecimal notation. So guys, let's see now how we're able to convert this particular number, for this case 0x44, into a decimal number. Remember, decimal number is base 10. So if we say we want to convert 0x44 into a number which we don't know, that is decimal number, which is of base 10, and this one is of base 16. So now that we know that, so let's do it now. So we know that this one is what we're having here is 0x, here is the notation, so we don't use it. What we are talking about is only this and this, like that. So first of all guys, you have to understand the position. Each and every value has a position. So we begin by this one has a position 0, when this one has a position 1. It starts with 0 and then 1. So let's now do it. What we do to convert into a decimal number, we multiply that one by 16 raised to the position it belongs. For example, let's say the first one, which is 4 to position 0, you say 4 multiplied by 16, that is now the base number, that is here, raised to 16 raised to 0, which is equivalent to say 4 multiplied by 1, which is equals to 4, guys. Let's come to the second one, that is the second 4. 4 multiplied by 16 raised to 1, which is equals to saying 4 multiplied by 16, which is equivalent to 64. So when you get the total is 68. That is enough to tell us that here, what we are having here as 0 x 4 is equals to 68 in base 10. This is base 16. And that is, we have converted that. So at that point, we have converted hexadecimal into decimal number. All right. So let's get into the next one. Let's get into the next one. That the next one is converting a decimal number into a binary number. The thing is, how can we convert a decimal number into a binary number? Let's have a look. So we have a number here. We will use what you're having just some minutes ago. So I will say I had 68 here in base 10. I want to convert it into a certain number which I don't know, which is of base 2. That is a binary number. So how can I do this? Remember base 10, this 16 is base 10. I want to convert it to binary. To convert a decimal number into binary, what we do here, we do a division. And when we do division, we take the remainders. So let's begin. Say, what we'll begin is say 68, guys, like this, divided by 2, which is the base of this one here, which will give us 34, like this. Remainder. What's the remainder? Remainder is 0. There is no remainder. So, and then we come again, we divide this with 34. We say 34 divided by 2, which will give us 17, remainder 0. There's no remainder again, because 34 times 2 is 17 times 2 is 34. Then we divide again 17. 17 divided by 2, which is equivalent to 8, remainder 1. Because 8 times 2 is 16 plus 1 is 17. So let's come to the other one, which is 8 now, divided by 2, which will give us how many? It will give us 4, remainder 0, so not 1. Then let's come again. We come to 4, divide 4 by 2, which will give us 2, remainder 0. Let's come also, we have 2 here. So 2 divided by 2, which will give us 1, remainder 0. We are not yet done, guys. Let's continue. We still have 1 here. So you say 1 divided by 2, which will give us 0, remainder 1. So how can we be able to create this one? So we take it in a reverse. So we take this one, we will begin with this. So you say we have 1, then we come to this, we say 0. We come to this, we say 0. We come to this, we say 0. We come to this other one, we say 1. We come to this other one, we say 0. And this last one is a 0. So 1, 2, 3, 4, guys. That is 1, 2, 3, 4. 1, 2, 3. So we add another 0 here to make it a full binary, that is in 8 bits. So we say that now 68, which is of base 10, is equivalent to a 0, 1, 0, 0, 0, 1, 0, 0. Yes, which is of base 2. And that is the binary value. But remember one thing, guys, you can have it in what we call binary notation. That is binary notation. How is binary notation? Our binary notation is 0, B, like this. That is a binary notation. So our answer now will be the same as say 0, B, and then now 0, 0. I'm sorry. So let me just first wrap this one. I don't need this one, this other one here. So I have only the 0, that is 0B here. That is where the bit notation ends, and then now this one 0 1 0 0 0 1 0 0. So this is now is the same as saying the binary of 68 here, base 10, is equals to this, or this one. This still works. It's the same. All right, we are done with that, guys. Let's get into the third one. That is conversion of binary into decimal. Conversion of binary into decimal. That is what we want to cover next. So let's add the next thing. So I will use what I'm using so that we will see how we're getting back there. So let me click on it here and say I want to convert. It was 0 B like this, and then 0 1 0 0 0 1 0 0. So this is my number. My number is 0. This is, remember, OB here, guys, here up to this end show the binary notation. So we assume this one. So we are talking about from 0 1 0 0 0 1 0 0. So how can we convert it back to decimal number? How can that be possible? Let's do it. Let's have it. So first of all, remember we are converting this to base 2. We are converting it into a certain number which you don't know, which is of base, which is of base 10. So that number is asked to be of base 10 because we are converting back to the decimal number. So let's do it. So I will say 0 1 0 0 0 1 0 0. Then I now begin to give position. This one is in position 0. This one is in position 1. This one is in position 2. This one is in position 3. This one is in position 4. This one is in position 5. This one is in position 6. And this one is in position 7. So guys, remember what we do to convert back to base 10. We multiply that number, the number given here, multiply by 2 raised to the power, the power of that particular position. For example, we'll say 0, the first one, which is this 0 here, which we are seeing here, 0 multiplied by 2. Remember the base is 2. 2 raised to 0, which is, this is 0 we are talking about. We are raising to this one. So 2 raised to 2, which is same as saying 0, guys, multiplied by 1, which means that anything multiplied by 0 will give us a 0. So I don't need to go through all this where there is zeros here. I'll skip all wherever we have zeros, because anything multiplied by a 0 will come up to 0. So I will go straight to where we have 1 here. You see here? Here. So I will say 1 multiplied by 2. Multiplied by 2 raised to, what are we raising to? We are raising to this 2. Raised by 2, like that, which is the same as saying 1 multiplied by 4, which will give us 4. Number 2, we come to here. The next one is this one. This is where you have 1. The rest are zeros. We don't need them. So we have where we are 1. So we'll say 1 multiplied by 2 raised to, we are raising to 6. You see here we have 6. So raised to 6 here, which is equals to say 1 multiplied by 2 raised to 6 is 64, which is equals to 64. So to get the decimal number, we add all of them and we get to 68. Are we getting back the number that we had? Yes. So it means that what we are having here are 0, B, then 0, 1, 0, 0, 0, 1, 0, 0. Base of 2 is equals to say 68. base of 10. Yes, we are done with that. So we are done with that, guys. Let's get into conversion of a decimal number into hexadecimal number. So let me wrap this. So decimal number into hexadecimal number. How can we do that? So conversion of decimal number into hexadecimal number. And what we are using in this case, we're using example that we had, that is 68. We want to convert it back to hexadecimal number. So our number here is 68 here, base of 10. And we want to convert it into a number which is x we don't know to base 16. How can we do that? Let's get into seeing each of them. So first of all, how you do it to get to a decimal number, you divide by the base of hexadecimal number. What's the base of hexadecimal number? It is base 16. The base of hexadecimal number is base 16. So let's see now. We have 68. We say 68, guys, like this. Divide by 16 here, which will give us 4 to give us 64. Remainder 4, like that. And then we divide now 4. We have 4 here. So you come and say 4 divided by 16, which will give us 0 because it's not enough. Remainder 4. So it gives us this 0 that cannot be enough, but our remainder of 4. So now, guys, we will begin from writing them from the bottom here, reverse this one and this one. So it means that 68, like this, base 10 is equals to giving us 4 in hexadecimal number. But remember, guys, we need to have what we call what? Hexadecimal notation. So our answer, decimal notation for hexadecimal is 0x. That is for hexadecimal. So our answer now will be 0x 4. And that is the hexadecimal number of 68. What can we conclude out of this? We can conclude this way that let me wrap. So let me wrap like this. So I can conclude and say this way that 68, like this, which is of base 10, is equals to 0x 4, which is of base 16, and it's also equals to 0 B 0 1 0 0 0 0 1 0 0, which is of base 2. That is what we can conclude out of this. That is 68 base 10 is equals to 0x44 base 16 equals to 0 B 0 1 0 0 0 1 0 0 base 2. That, guys, we are done with that. Let's get now into solving the quiz. I find this one as necessary because it will help you to be able to solve the quiz. So now, guys, let's get now into the task. And what we are doing is that, as I said earlier, is that this is being the fifth part of the outline that will cover now the quiz. And the quiz, I will not just give you the answers of the quiz, but I will guide you through to understand why or what is the reason as to why I'm arriving to the answer I'm giving in this case. And I will explain to you each and every part of it. Let me try as much as I can to give you what explanation I can. So first thing is that we need to understand this is what we'll be covering, that these are the tasks we are having here. These are the tasks, and the task is that we have been given this one. So in this case, we have been told this one. Okay, this one means something. This one means something. That this one we are negating. Where we have 0, we have it to 1. Where we have 1, we have it to 0. The question is, where is 0 and 1 coming from? So first thing that we have to do this one is we want to change this one into binary for us to be able to change where there is 0 to 1 and where there is 1 to 0. So before that, guys, you have to understand that it has to go through a process. One is that here is in hexadecimal number. What we are having here is hexadecimal number. Someone might be asking, why do we say that this one is hexadecimal number? It is hexadecimal number because of 0x here. 0x is what you call hexadecimal notation. That's able to tell us that this particular number here is hexadecimal number. So let's get into it and have let's have like this. We are having a 0 x 1 2, which we have been given, which is of base 16. And then what we have to do first of all is we are converting it into a decimal number. How can we convert it? We are looking for a value which we don't know, which is of base 10, meaning that we are looking for a value which is a decimal number. How can we do that? Remember, this one is not part of what we have to calculate. What we only calculate is 1 and 2. So first of all, we have 1 is 0 x 1 2 like this. So we have to know that this one is in position 0, this one is in position 1. So what we do to get a decimal number, we will multiply a given number, for example 2, which is the number, multiply that particular 2 by the base. What is the base? Our base in this case is 16, because the base of that particular number is 16. So 16 raised by the power of its position. The position is 0, so power 0, which is equal to, say, guys, 2 multiplied by 1 for us to be able to get to 2. Let's get the second number, which is 1. So 1 multiplied by 16 raised to the power. Power is positioned in 1 raised to 1, like this, which is equal to, say, 1 multiplied by 16, which will give us 16. So now that we are at this point, what's the total? The total in this case gives us 18. So this is enough to say that 18 base of 10 is equivalent to x 0 x 1 2 base of 16. And that is, we have achieved in the binary. Let's get into having it in okay, this is not binary, this is decimal. Let's have it in binary now. So we have 18 in decimal, change it into binary. So we have 18 like this to base 10, and we are looking for another value which is x to base 2. We don't know this number, but we're looking for a number which is to base 2. How can we do that? We do that by dividing the decimal number, divide by the base of which the number we are looking for, which is 2. So we will say 18 now divided by 2, which will give us 9 remainder 0. That is the number. Okay, now that we have this 9, we come and say 9 divided by 2, which will give us 4 remainder 0. No, remainder 1, I'm sorry. Then we have now 4 here. So it's say 4 divided by 2, which will give us 2 remainder 0. So we have now 2 here. So it's a 2 divided by 2, which will give us 1 remainder 0. Let's have this one. So 1 divided by 2, which will give us 0 remainder 1. So guys, now let's get into it. So let's in a reverse order. We'll go in a reverse order. So we'll begin with this, which is 1, then get to this, which is 0, get the other one, which is 0 here, then get the other one, which is 1, and get the other one, which is 0. So like this. So this one to base of 2 is equivalent to, say, 18 base of 10. Now that after we have achieved this one, guys, we want to make it into what we call 8 bits. For it to be complete, we need to make it into 8 bits. So in this case, we have how many bits? 1, 2, 3, 4, 5. So we still need to add 3 more bits to make it 8. How can we add that? So we'll say we have 0, 1, 0, 0, 1. Then we need some other figures here. How can we add? We will add another 0, another 0, and another 0 like this. So now this is now complete 8 bits like this. So since this one, we need to have this is our answer, but our answers are in hexadecimal number. How can we be able to get our answer now back to hexadecimal number? We need, guys, first of all, this one we convert, use what we call the bitwise OR, exclusive OR, I'm sorry. This is exclusive OR like this, which will mean that where we have 0, it will negate, where we have 0 to get 1, and where we have 1, it will negate to 0. Let me wrap up here. So let me just go back here. Let me wrap here. So now that what we have to understand that after you have get a particular answer, which we will get out of this, after we get that particular answer, what we will do is that we will convert that particular answer into hexadecimal number, because our answers given there are in hexadecimal number, and at that point we're able to achieve our answer. Let's get to see. So this is what you have, guys. This is what you have now. The new 0, 0, 0. Okay, I'm copying this one as it is. And then 1, 0, 0, 1, 0, like this. And then now let's do the negative side. So where we have 0 here, we will have it as 1. Where we have 1 here, we will have it as 0. Then here is 1. Here is 1. Here is 0. Here is 1. Here is 1. And here is 1. So this is what we are getting, guys. This is now our answer. But what next? We want to convert this answer back to it. We want to convert this answer to hexadecimal. Now that we have, when we convert this answer into hexadecimal, we will be able to get our answer there. So now, first of all, we need to understand that this one, the basis of this one. So each of them has its own base. For example, let me write 1, 1, 1, 0, 1, 1, 0, 1, like that. So this one is in position. This one is position 0, position 1, position 2, position 3, position 4, position 5, position 6, position 7. So since we want to convert it into hexadecimal number, I will first convert it back to a decimal number, because that will now be easy for me to convert it back to hexadecimal number. How can that be possible? Let's see. So we multiply a number given, multiply by the base. So I will say, for example, I have the first one here. So I say 1 multiply by base 2. So 2 raised to 0, which is equivalent to saying 1 multiplied by 1, which will give us to be 1. And then the second one here is 0 multiplied by 2 raised to 1, because position 1, here is position 1, which is equals to saying 0 multiplied by 1, here is equals to 0. I don't need to calculate where we have 0, so I will skip. So there's no need for this one. So let me calculate to this one, this other one. So I'll say 1 multiplied by 2 raised to position is 2, raised to position of 2, which will give us, it's like saying 1 multiplied by 4, which will give us 4, like that. So let's come to this other one, that is position 3. So 1 multiplied by 2 raised to 3, which is like saying 1 multiplied by 8, which is equivalent to 8. Let's go skip this one. Let's go to number 5. So we'll say 1 multiplied by 2 raised to 5, like that. And then is equals to 1 multiplied by 32, like this, which is equivalent to saying that this is 32. So let's get the other one, that is this one, 6. So 1 multiplied by 2 raised to 6. So this is equal to saying 1 multiplied by 64, which will give us 64. So let's come to the last one, that is 1 multiplied by 2 raised to 7, which is equals to 1 multiplied by 128, which is equals to 128. So that is now equals to all these ones. So what we need to, for us to get a decimal number in that case, we will add all these numbers. That is 1 plus 0 plus 4 plus 8 plus 32 plus 64 plus 128. And if I'm not wrong, what will give us is that it will give us 237 to base 10. That is the answer. But now let's convert it now to the last step, converting back to hexadecimal number. This is, we are converting it into an x which you don't know, which is 2 base 16. How can we do that? So we divide. So we just say begin by 216. I'm sorry. Let me wrap this one. Let me wrap here. Yes, let me wrap like that. Right, let's continue. So 237 divide by 16. What will it give us? It will give us 2 that's divided by 16 will go for how many times? Let me calculate. It will go for 14 and then remainder 13. There will be a remainder of 13. Then now we divide this 14 again. Come and say 14 divide by 16, which you all know that not enough, so it means like to go for 0 times remainder 14. But in hexadecimal number, what do we mean by 14 and 13? In hexadecimal number, you can see here, where is 14? 14 is this one. 14 is this one, which represent what? E. And then 13 represent D. So we'll begin by this one in that order, in the reverse order, which means our answer will be, instead of 14, we will write E, and instead of 13, we will write D. So it's ED. But remember one thing, we need to have what we call hexadecimal notation, meaning that it must have something like 0x and then our answer there. So it will be like this. It's like saying our answer will be 0x E D. That will be our answer. Let's check if we have such kind of answer. So let's get here. Yes, we have 0x E D, like that. So that will be our answer now. Yes, so we are correct. Now let's get into the next question. That is this one. Okay, guys, from this point, I have used the first example to show you each and every step that you go through for you to achieve each and every part of this particular task. But now, because I want to save on time, but I will explain each and every part of this. But some of it I will leave for you to be able to calculate by your own. Like for instance, the second question says that 0x88 and 0x, that is now 0x01, this one. So what I will do, I will just write for you and show you what is the case. So let me wrap all this. Now that we are done with this, I believe you understood that particular question 1. And now that you have understood, you will be able to calculate this second one by your own. But I will guide you through. What you have is that you have been given as 0x8 and something like that, and 0x01. So first thing you have to know is that these are what we call hexadecimal notation, these two. So we need to find these numbers. First of all, they are binary values. What is the binary of this 0x088? So let me show you. I hope you will calculate by yourself. You can calculate by yourself, but when you calculate, you will arrive at the answer of 088 which is equivalent to 1 0 0 0 1 0 0 0 as its binary number. So this will be the binary number of this one. If you calculate, you remember how to calculate? If you don't remember how to calculate, go back to this where I begin this video and I was showing you how to be able to calculate between an hexadecimal number into binary. So first of all, you change that hexadecimal number into decimal number, from decimal number into binary. So now that we'll go all through that process until you will achieve this one as the binary of this particular number. Now that you get the binary of that particular number, we get now the binary of this other one, which is 0x01, which in this case is like saying 1. It's like saying 0 0 0 0 0 0 0 1. So that will be our binary for this one. So what next? What do we do next? In this case now, we have been given AND. This is what we've been given. AND is what we have been given here. So what are you supposed to do? AND is AND. What happened is that in AND, they have two values. We have A and B. And then we have 0, we have 1, we have 1, we have 0, we have 0, 0, we have 1, 1. So whenever, what does this tell us is that whenever when both of them are true, then that is when it becomes true. When both of them are 1. So here in this case, 0 and 1, it will give us 0. 1 and 0, it will give us 0. 0 and 0 will give us 0. So only instance when we have 1, 1, it will give us 1. So let's come in this case now. 0 and 1, it will give us a 0. 0 and 0, it will give us a 0. 0 and 0, it will give us a 0. 1 and 0, it will give us a 0. 0 and 0, it will give us another 0. 0 in that order, and 0 and 0. What is this equivalent to? This is like saying that this one is equivalent to 0 x 0 0 in hexadecimal number. So this is what we expect to be our answer, 0x00. Let's get into, do you have answer like that? Yes, we have answer like that, which is this one. So we have this one. So we have answered that one. Let's get into another one. The next is, what is this one? Base 2. So let me get and see. So I've shown you that we have now that one. Let's get into this other one. We have been asked to do what? 98 in base 2. So we have 98 like this, which you know that 98 in this case is in base. It is in decimal value. Where is it? Here. Decimal value. So this is to base 10. We have been asked now to calculate the binary, which is we are looking for x, which we don't know, which is of base 2. So how can we do that, guys? We will calculate by saying 98 divide the base value, which is 2, which will give us 49 remainder 0. Then we have that 49 now. We get 49 divided by 2, which will give us 24 remainder 1. So let's come to 24 divided by 2, which will give us 12 remainder 0. Let's come to 12. 12 divided by 2 is equals to 6 remainder 0. Let's get to 6. 6 divided by 2, which will give us 3 remainder 0. Let's get to 3. 3 divided by 2, which will give us 1 remainder 1. Then let's get to 1. 1 divided by 2, which will give us 0 remainder 1. like that. So in a reverse order, we will have something like this. We will have something like 1, that is from this one, 1, that's from this one, and then 3 zeros from this, and this. So 0, 0, 0, the 3, and then 1, 0, then 1, 0. But another thing you have to notice, guys, you have to have it into 8 bits. Remember 8 bits? For it to be complete, you must have it in 8 bits. And then, so how many bits we have? We have 1, 2, 3, 4, 5, 6, 7. So we are adding only 1 0. So we are having like this 0, 1, 0, 0, 0, 1, 1, like that. And then we are adding 1 0. So 0. So that make now 8 bits, right? And then we need to add what we call the binary notation. Binary notation is like this 0, B. So we add here 0 and then B like this. This is now our answer. Let's get and see if we have such kind of answer. Let's get into here. Where is it? This one. This one is the answer. Now let's get into the next question. Okay, in the next question, guys, what we have been given, let me just wrap in this one first. So in this question, we have been given that this is the number that have been given, that is 0b, 0, 0, 0, 10, then 110. Okay, let's have the number as 0b, that is the first thing, and then 0, 0, let me check once again, 0, 0, 10, 0, 0, 10, 0, 0, 1, 0, and then 100. I think so. Let me check again. 100 and then 10. Yes, 100 and then 10 like this. So these are now 8 bits now. Okay, first of all, assume this other part. Assume this other part. What are you able to understand? Why do I say assume? This is what we call the binary notation. It is served at the end of binary notation. So you don't count from this. So you will count from what you are having here. And what have you been asked? You have been asked to calculate it base 10, meaning that you have been asked to calculate it in decimal number. So this is to base 2, and you have been told to calculate a value which you don't know to base 10. How can we do that? We multiply this one. We must check that this one is in position 0, this one is position 1, this one is in position 2, this one is position 3, this one is position 4, this one is position 5, and this one is in position 6. So, and then this one is position 7. But I will just multiply where we have 1, because these other numbers multiplied by 0 will still give us 0. And there's no need for having zeros all this. So we'll just go to where we have 1. I'll just say 1 multiplied by 2. Remember the base is 2. Raised to the power of its position. This one is in position 1. So raised to 1, which is equivalent to say 1 multiplied by 2, which will give us 2. Let's get the next one. The next one is this one. This one is in position 0, 1, 2, 3, 4. Is in position 4. So 1 multiplied by 2 raised to 4, like this, which is equal to say 1 multiplied by 16, which is equal to giving us 16. Right, let's get to the other one, which is position 4, position 5, position 6. So 1 multiplied by 2 raised to 6, which is equivalent to say 1 multiplied by 64. So what, guys? It will give us 64. The addition of all of these will give us the answer. So 16 plus 64 will give us 80 plus 2, 82. So our answer now will be 82. And that is how I arrived at my answer to be 82 like this. Let's get to the third one. Third one is 0x00. So this one I will not do because I will not do to calculate this one, but I will show you how to be able to calculate that. So 0x01, 0x00. So now let's have like this. So we have 0, x, 0, 1, and then what have we been asked? It is and. So I will use, let me use this one to show the difference like this. No, you know that way. Let me wrap this. That is not the case. Let me wrap like this. Now let me use and. So and is like something like this. Then and what? And 0 x 0 0. So first of all, we need to find the binary of this one. Remember binary, how to calculate binary? We will calculate binary by calculating this one also first of all into decimal, and then from decimal into binary. So let's have it. So we have it as 0 x 0 1. When you calculate its binary, you will get something like this. What is the answer? You will get something like this. Let me show you. You will get something like that is 0. Remember 0 is like 1, 0 0 0, and then 0 0 0 1. And then where we have now the second one, 0 x 0 0, which will give us what? What will it give us? It will give us a 0, a 0, a 0, a 0, a 0, a 0, 0, and lastly 0. Actually 0. There's nothing in it. It's 0. So what are we being asked? And means that we're using this and will tell us that whenever we have only 1 and 1, if we don't have 1 and 1, so these instances in this case now is able to tell us that all this one and this one is 1 and 0, so it is not 1 1, so it will give us 0. The rest all the way it will give us 0. It will give us 0. All this it will give us a 0 like that. I believe yes, it will give us 0 like this, which is equivalent to saying it will give us a 0 x 0 0, and that will be our answer. So where do you have that? Number 4. This will be our answer like this. Let's get to number 5. Number 5 is 089 and then 081. So we say that number 5 we have something like this as 0 x 8 9, and then and. Is it and? Let me check. It's and. Yes, it's and. So and something like this, and 0 x 0 1. If I saw it wrong rightly, yes, like that. So let's get into now. So first of all, I say we need to find the binary of this one. So the binary of this one, which you will calculate, you calculate on your own as I've showed you. So will be 0 x 8 9, which will give us its binary value will be equivalent to saying that it is 1 0 0 0, and then 1 0 0 1, like that. It's equivalent as saying like that. Then we have another one, 0 x 0 1, which is equivalent to saying that this one is equal to 0 0 0 0 0 0 0 and 1. And then what are we being told? And tells you that wherever we have only 1 and 1. So this also will give us a 0, 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 a 0. And that will translate to say that that number is equal to x 0 0 0. Yes, and our answer will be this one. Now let's get to number 6. Number 6 is giving us like 98 by 16. So number 6, we have been given 98 by 16. So 98 like this, which is in base 10, when we have been given to calculate a number which is to base 16. How can that be possible? And our base to 16, like say 98, that's that number, divided by 16, which will give us how many times? It will go for 6 times, and the remainder will be 2. So we divide that 6 again. 6 now divide by 16, which will give us a 0 was not enough, remainder 6. So our answer now will be in the reverse order will be 6 and 2 like this. But remember one, don't forget they will call the hexadecimal notation, which is equivalent to saying 0 and x. So our answer will be 0x62. Let's get and see 0x62 here. So that's our answer. Let's get to number 7. Okay, so question 7. Okay. Okay, guys, there's something I'm noticing here. This is and. I said and is where we have one. I see this one is wrong. We have one here and we have one here. So guys, I'm sorry for this. See, this is supposed not to be 0 here at the end. Supposed to be 1, because 1 is become true this one. So our answer will not be this one. So our answer will not be 0x0, but it will be have a 1 in it here. So it will be 0x01. So number 5. This was number, yes, number 5. Yes, so number 5 here. So answer is this one, no the other one. Sorry for that. Let's continue. Question number 7. Question number 7. Number 7 is 089, and then there is this thing. Now you're getting to see a new thing. Okay, this is shift to the right. You're shifting to the right. So you have first of all this into binary, then from there you shift to the right. So let me show you now. I will not calculate the binary of it, but you already even have here. For this one, you already have it here. For this one, so I'll just change here. I have it here, and what I'm changing is here. And then I'll just only include this one. That is like this, and you are shifting how many steps? Okay, this one tells you the number of steps you are shifting 3 of them. So and then okay, that is it. So you are shifting 3 of them. So I will wrap this other one. Let me wrap this one. I don't need them. This other one here, I don't need them. So now I have this one now. So we have been given that the binary of this one is equals to this one. I don't need to calculate. But now let's come to this shifting. What does this entail? Shift is that I am moving my bits shifting to the right. So shifting to the right, what does it mean? It means that this one, let me use this. It means that this value here will move to this step, and this one will move to the next step, and this one will move the next step, and this one will move the next step, like that, until we reach here, and then this one move to this step, this one move the other step, this one move the other step, this one exit now. So this one will be truncated. Then the second step, this one will be truncated. The third step, this one will be truncated. So all this will be truncated. We will have remain with the answer like this will be the first one on the other end. So this will be have 1 because this one will be gone. This one will be gone. So we'll have 1, which is this one. We'll have 0, which is this one. We'll have 0, another one, which is this one. We have 0, another one, which is this one. And we have 1 here, which is this one. And then these are not 8 bits, guys. So we add another 0 here, 0 here, and 0 to make them 8 bits. But also remember one thing. Let me check. Remember one thing also. We must have the binary notation. Binary notation is like 0 and B, like this. So you need to add 0 and B to represent the binary notation. This is our answer now. So let's check our answer. Where's the answer? Okay, where is it? It was this one. Okay. Oh, I haven't changed into binary, into hexadecimal. So let me change this one into hexadecimal. When we change into hexadecimal, you will get something like this. I believe you will get something like 0, 0, x, 1, 1. When you calculate this one into binary, I believe you know how to calculate in binary. If you don't know, please go back where we convert binary in decimal to hexadecimal. So this is it, 0x, 1, 1. So our answer is this one. Let's get to number 8, 0x9, 89 in base 2. Meaning that you are converting this one into binary. You are converting that one into binary. Okay, let me show you. Okay, so you have been given 0 x 8 9 into binary, right? Let me check. You have been given that one into base 2, so into binary. So into an x which we don't know. First of all, you have to convert into base 10, so that is in decimal. Then what you get here, that x which you get, which is in the base 10, you convert it into x which is base 2. So what we will get here, I believe there's something we'll get here in this value. Let me just give you. So this one will be 137 if I'm not wrong. Okay, I'm not sure about this. You can check about this. I think this one is 137 in decimal number. So assuming that we have that 137, then we have 137 now. You convert it into binary, for which that you will get a binary value which is like this. It will be like 100, like 100 like this, and then 1001, and that will be in binary form. But remember binary notation. So we'll be having us as 0 b, and then now this number which is 1001. That is will be our answer. Let's check. Yes, so this one is the first one here. So let's get to number 9. We're going good. Number 9, 0x01, 0x01. Yes, it is OR. We are using OR. So let's get into it. Let me wrap this one. Yes, now wrap. So let's get into, we have been given 0x01. And then we have been told OR like this. And then 0x01. So first of all, we need to find the binary of these numbers. We need to find the binary of these numbers. So this is in base 16. This one is in base 16. So we get the binary of them. So the binary of 0x01 is equivalent to 0, 0, 0, 0, 0, 0, 0, 1. The same case to the other one, 0x01, which is equivalent to 0, 0, 0, 0, 0, 0, 0, and 1, like that. And then remember this is OR. OR means that whenever you have at least one, whenever you have either 1, 0 or 0, 1, it will still accept as a true. Or at least to assume even if it is 1, 1, it will be true. So this one also, only this end will be true here. But the rest are zeros. The rest are zeros. Like that. We'll have it like this one. But remember one thing, we want to change it back. We want to change it back to hexadecimal because our answers are, I believe so. Yes, our answers are in hexadecimal. How can we change? If we want to change the decimal, we first say that number which we have, that number which is of base 2, we convert it into a number which is base 10, that is that particular number, and then that particular number which we will get to base 10, we convert it back to x base 16, which at the end of the day we'll get an answer like this one. This is like this one. So this x 0, 0, 1 is in hexadecimal. This base 16 like this. So this one answer x 0, 0, 1. So let's get a C. 0x01 like this. So that will be our answer. Let's get to the question number 10. We have been given this one, but we have been asked to shift to the left. That's the left shift. The left one step. So let's come here. I will not wrap all this. Let me wrap some of it. So I will just wrap this. I don't need this. And also I will wrap one of this. Yes. So let me, we have been asked to shift. How many steps? One step. So first of all, you need to find the binary of this. What's the binary of this? The binary of that is this what we are having here. We are having 0, 0, 0, 0, 0, 0, 0, 1 up to this end like this. So what are we supposed to do? We have been told to shift 1. So meaning shifting that this other one here will move. This one will move to this end. And the same case, this one will move to the other end. What will happen to this end here? Now one will have moved to this end, which will mean that we'll have 0 at this. I'm sorry. We will not have 0. Let me wrap it. We will have 1 in this end. So these when they are shifted, this will have 1 here. What will happen? What will remain at the other end? We will have a 0 to replace where 1 was. Then the rest of it shift also. So at the end of the day, we will get something like this. At the end of the day, we'll get something like this, which is equivalent in hexadecimal number. It is equivalent to say 0x, which is 02, I think so, like this, in hexadecimal, like that. Let's check. Where was it? Number 10. We have it here. So these are answer here. So let's get into number 11. Number 11 says that 0x13, and then you go left shift also 1 step. So 01x3. So let's get back here, and I will wrap all this. Yes, let's get back it and then say that we have been given 0x13, and we have been told to shift 1 step. So first of all, we need to find the binary of this. We first calculate decimal, then decimal into binary. So our binary for this case will be 0x13, which its binary value will be equivalent to say 0, a 0, a 0, and a 0 like this. And also we'll have, okay, no, there's another one. I think there's, I forgot this. So instead of 0 here, we'll have 1, and then we have 0, 0, 1, 1, like that. So we'll have it like that. So that is the binary value of this number. Then from there, now we shift to the left, meaning that where we have 1, it will shift to this where we have another 1, and this other one will shift to this other one, and then 0 will shift here. So at the end of the day, we will get where we add 1 here will be 0, because now 1 will have shifted. Now we have remained 0. Where we have 1 here, we'll have another 1 which are replaced. So we have 0 here, we replace with another 1. Then 0 all the way like this. Is it okay like that? Because I have 0 here, I've replaced here with 0, and I've replaced this other one with no, I'm moving where am I moving to? Let me check. Moving, yes, I'm moving that end. Yes, let's check. Is it moving the other end really? Because I will have this one like this. Yes, so you have this one, and then what next? You have, so we will have like this, another 0 here, like this, and then we will have 1 now. So this one, like this. Then we have 0. Then we have 0, like this, something like that. This is for, yes, these are 8 of them. So we'll have something like this. So this one. So now this one is in binary, but our answers are in they are in hexadecimal. So we have to convert to hexadecimal. So when you convert this to hexadecimal, which I will ask you to do it by yourself, because I've shown you how to do it actually. So we'll just try it by yourself. It will give us something like equivalent to 0x26, like this. So let's get to our answers and see. So we'll have our answer to be this one. Let's get number 12, 098, like this, and then you've been told this one is like the first one. The first one you are given 0x12. So this one 098, but we negate. So let's have it like this. We have been given 0x98, but we have been told something like this. So first of all, we need to find the binary of this number. So the binary of this number, which I will require you to calculate, this one like this, its binary value will be equivalent to saying that it is 1, 0, 0, 1, 1, 0, 0, and 0. It is 3 of them. 3 zeros. So let me write it here so that it will be fine. Write it here to be 1 0 0 1 1 0 0 0. So these are 8 bits, yes. And then now we negate where we have 0, we have it to be 1. So where we have 0 here, we are having it as 1. Where we have 0, 1. Where we have 0, 1. Where we have 1, 0, 0. Then 1, 1, 0. So that's what specifically we will get. So, and then what next? We will need to calculate this back to the hexadecimal values. So when we calculate this one to hexadecimal value, it will give us something like 0x67, like this. So this will be our answer. Let's get into it. So this is our answer. Let's get to number 13. Number 13, we have been given 0x1, 0x0. So we have been told to calculate OR. Remember OR. So first of all, let's get into there. So we have, we are saying that we have, what are we having? We are having a 0, a x0, 1, then OR 0, x0, 0. I believe I wrote it correctly. Let me check. Yes, it's correct. Now let's get, so first of all, we need to find the binary of this. So the binary of 0, x, 0, 1. Its binary will be equivalent to saying 0, a 0, a 0, a 0, then a 0, a 0, a 0, and 1. Then we come to the binary of x00, like that will give us a 0, a 0, a 0, a 0, a 0, 0, like this, 0, and lastly 0 like this. So let's get OR. OR means that at least one of them is true. So here 1 and 0 is 1. So this one is at least 1. The rest of the numbers will be equal to 0. The rest will be 0. The rest will be 0, guys, like this. And this is in binary. We need to convert our answer back to decimal, no, back to the hexadecimal, because our answers are in hexadecimal. So let's convert it back. When we convert it back, we will get something like this. This is 1, like 1 in hexadecimal. 1 hexadecimal will give us 0x0, 1. So this is our answer. Let's get into it. So this is our answer. Number 14. We have been given this one, and then we have been told to shift 1. We have been told to shift 1 to the right. We have been told to shift 1, shift 1 step. I'm sorry. So let's come here. So let's come here. So we have been given a 0, x, 0, 2, like that. And we have been told that we are shifting to what direction? To the right. So shift 1 step. So what are we doing? First of all, we need to have the binary of this, and then we shift. So binary of 0, x, 0, 2, like that, which is equivalent to having it as 0, 0, 0, 0, like that. Then 0, 0, 0, 1, 0, like that. Then what we do next? We shift. We are shifting to the right. So we are moving this. We are moving this one here. 1. We are moving this end. This one, this end, all the way. All the way. We are moving each to 1 step. So we will have something where this one will come to the end. So we have 1 at the end, and then the rest which are following this one are zeros, like that. What are following this one are zeros, because I will add another new 0 here which are shifted. This one will be 7 zeros, but I will add another new 0 here which will replace the one removed here. So our answer will be like this, which in hexadecimal value will be equal to 0x01, and that will be our answer as this one. Number 15. So number 15, guys, we are asked to calculate this one into base 16. We have been given binary and asked to calculate into base 16. How can we do this? It is 0b 0, 11, 10, 11, 0, 1. So let me wrap this one. So we have it as 0, B, that's the first thing. Then from there, it is 0. Let me check again. It is 0. Yes, 11, 10, 11, 0. And then from there, it is 11, 0, 1. 11, 0, 1. So what have been asked? We have been asked to calculate to base, which base? Base 16, changing to hexadecimal. So in this case, we have to, first of all, we have this number, which is in base 2. We convert it back to a number base 10. So whatever that number will get there, which in this case will get 109, I believe so. Something like 109, like that. And then we have that 109, which I believe it is that we can confirm. If in case I gave the wrong information, please confirm. This 109, this is to base 10. We have to calculate to get another value, which is to base 16. And how can we get this one? It will be saying 109 divided by 16, which will give us 6 times. Then the remainder will be 6 times 96 times 6 is 96, which is remaining 13, remainder 13. Then we have now 6 divided by 16, which will give us a 0 because not enough, remainder 6. So in the reverse order, we will write it as 6 and 13. But remember what, guys? 13 is equivalent to D in hexadecimal. So 13 is equivalent to D. So we'll have it as 6D, like this. But remember one thing, don't forget hexadecimal notation, which is 0x. So our answer will be 0x6D. And that will be our answer. Let's get back to it. Yes, we have it to be 0xD, like that. So let's get to this number 16 now. Number 16, we have been given 066 and is 022. So let's get to it. So we have it to be 0x66 and then end 0x22, like that. So first of all, we need to find the binary of this and the binary of this, and then we do the AND. So what's the binary? We have a 0x66 in binary will give us what will it give us? Let's check what will give us. Okay, I will ask you to calculate. For this case, I will just use this, which is equivalent to saying 0 1 1 0 0 1 1 0. That's like this. Yes, like this. Then what about 0x22? 0x22 will give us a 0 0 1, like that. Then 0 3 zeros, I guess 3 0, like that. Then 1 0. That's equivalent to this one. So that is 8 bits, right? Yes, 8 bits. So now we do the AND. AND means that it will only be positive, or it will only be 1 where we have both of them are 1. So here and there it is 0. 1 and 1 we have 1. 1 and 0 0. 0 and 0 0. 0 and 0 0. 0 and 1 and 1 1. 0 and 1 0 0. So we'll have something like this. So let's convert it back to hexadecimal value. How do we have that? Our answer will be in hexadecimal number will be a 0, a x, and a 2 2, like that. That will be the same thing. We'll have something like that. So let's get into it. Let's give our answer. Where is it? Our answer will be here. Number 17. Number 17, you have been told this one into base 10. This is very simple. This is very simple. I don't think even I need to calculate, but let me just. So we have been given that we have to have a 0 like this, x 8 9. And then calculate into what? Base 10, which is an x to base 10. So what we do, we divide that number by, no, we don't divide, we multiply. So we come and say by its position. So this is in position 0, this is in position 1. So how can we do that? So we begin by 9, multiply by the base of this is 16. So multiply by 16 raised to this position, which is 0, which is equivalent to saying 9 when we multiply it by 6, and not 16, it's 1, is equals to a 9. Then let's come to another one, which is like saying we multiply that one by that is 8, multiply by 16 raised to 1, which is equivalent to saying 8 multiplied by 16. What will it give me? Let me do the calculation. So this will give me 128, I think so. Then when you add 128 plus 9, it will give us 137. And that will be our answer. Yes, question 17. Yes, we have it here. Question 18. We are about to finish, guys. Question 18, 0x01 and 0x01. So we need to find the values. So in this case, I will say we have a number called 0x01 and 0x01. So we need to find the binary of each. So how can we do it? You say binary is 0x01. Its binary is equivalent to 0, 0, a 0, a 0, a 0, a 0, a 0, and a 1 at the end. So another one, 0x01 will give us a 0, 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 and a 1 at the end. So and means that when both of them are only 1 is when it gives us 1. So here is 1. The rest is 0. The rest is what you're having is 0. So it's only 1 and then the rest are 0. Which in this case it is equivalent to saying that we have a 0x01. That is our answer. So this is it. The last one, number 19, guys. Number 19, let me write. So our number 19 in this case, we have been given to be 0x4 and or 0x2. So let's have the binary of this. The binary of 0x4 is equivalent to a 0, a 1, a 0, a 0, a 0, like that. 1, 0, 0. These are 8 bits, yes. And then we have a 0x0. I'm sorry, it is 2, 2, which is equivalent to saying it is a 0. It is a 0 again, like this. It is another 1, then a 0, a 0, a 0, and then a 1 and a 0. Are they 8 bits? Yes, they are. They are 8 bits. So now let's add. Now this is OR, meaning that whenever there's existence of 1, that becomes true. So our answer now will be 0 and 0, 0. 0 and 1, 1. 1 and 0, 1. Then the rest are zeros because this one goes this because there's 0, then 0, then 1, then 1, then 0. Yes, because this goes with this, 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 this and this, this and this, this and this. Yes, so we get this one. Then we have to convert it back to hexadecimal. To hexadecimal, we will get something like 0x66, like that, guys. So now let's get our answers. This one. Then we are done with that. Let's submit. Yes, we are done. We are done with that. It says, what does it says? You have completed successfully. Thank you very much, guys, for following up to this, and I believe you have been able to understand each and every part of this tutorial. If you haven't understood, kindly go back to where you feel like you are lost and try to understand. If you didn't understand the conversion, go back to the beginning of this video and get to understand how we did the conversion. Thank you very much for listening to us. See you next time in the next video. Bye bye. Don't forget to subscribe to our channel and refer someone else. Bye bye.